Alright everybody, what's going on? This video we're going to look at functions of several variables. Shouldn't be too long of a video, but let's go ahead and get started. So let's look at definition. So the definition, a function of two variables is a rule that assigns to each ordered pair of real numbers x, y in a set D a unique real number denoted by f of x, y. The set D is the domain of f, and its range is the set of values that f takes on. So, you can think about when you learn linear functions. So the x, y, that's the numbers you plug in, and then the f of x, y, that's the numbers that come out, like plugging in your x values and getting out your y values. So the set D is the domain of f, and its range is the set of values that f takes on. That is f of x, y. So we've got the set of all f of x, y such that x, y is an element of the domain. Now, let's look at some notes here. We often write z equals f of x, y. So, a lot of times what we'll do is you may have a function written f of x, y equals something, and you'll see in just a minute in the examples. But sometimes what we'll do is we'll take that f of x, y and we'll replace it with a z. Okay, it's kind of like if you think back to the linear functions from college algebra and stuff. You would write y equals, say, 2x plus 1, and sometimes you could write f of x equals 2x plus 1. Okay, x and y are your independent variables. Z is the dependent variable. And a function of two variables, the domain is a subset of R2, and the range is a subset of R. All right, so think about it. You're plugging in a point from R2, an XY you're plugging in. But the number that you're getting out, you're just getting out a single number as a solution from the range. So your range is a subset of the real numbers of R1. All right, so let's look at an example. So it says, for each function, evaluate f of 3, 2, and find and sketch the domain. All right, so we're going to learn how to evaluate one of these functions, and we're going to find the domain, and we're going to draw a picture of the domain. All right, so first thing, let's go ahead and just evaluate f of 3, 2. So if we evaluate f of 3, 2, so remember, this is your x, this is your y. So you're plugging 3 in for x, you're plugging 2 in for y, and so that's going to be the square root of 3 plus 2 plus 1 over 3 minus 1. And so this is what? This is the square root of 6 over 2. And there's your answer. Is that easy enough for you? Not too bad. All right, now let's sketch the domain. But before we sketch it, let's find it. Let's find the domain, and then we'll sketch the domain. All right, so let's see. What do we know about this function here? Well, there's a couple of things. Well, we have a square root. So if you have a radical that has an even index, remember the index, that's the, like here you got cube root, or you can have fourth root and so on. And when there's not a number there, it's understood to be a 2. That's square root. So if you have a radical that has an even index, well, you can't have a negative number underneath that radical. I mean, you can, but it would be an imaginary number, and we're dealing with real numbers. So we know this part that's underneath the square root, it can't be negative. Can it be 0? Yeah, it can be 0 because the square root of 0 is 0. All right, so we know that x plus y plus 1 has to be greater, we know that x plus y plus 1 has to be greater than or equal to 0, right? Can't have a negative under there. This right here can't be negative, what's underneath the square root. But there's also something else. And we also know that x cannot equal 1. Because if x is equal to 1, then we would have 0 in the denominator of the fraction. Okay? All right. So what do we do? What do we do now? Well, we write our domain. All right. So the domain is equal to the set of all x, y such that, well, here's our conditions. X plus y plus 1 is greater than or equal to 0, and x does not equal 1. And so there's your domain. See how easy that is? Nothing to it. It's a piece of cake. All right, I didn't leave myself a lot of room there, did I? So now we need to graph the domain. Okay, so let's graph the domain. And so I'm going to graph the domain on the XY plane. See, I got XY is what I'm plugging in. All right, so the thing I need to do is I need to graph this line here, because I know the domain has to be greater than or equal to this line here, right? That's what we know. So for this, I can actually write this. Let's see, x plus y plus 1 equals 0. Well, I can say y is equal to negative x minus 1. Just go ahead and solve it for y. Makes it easier to graph. There's your y-intercept. Y is equal the negative 1. My slope is negative 1, so that means I'll go down 1 and to the right 1. And there's another point on the line. And so now I can draw my line in there. But we also know that x cannot equal 1. So this line right here, I need to put this in here, this dotted line showing that x cannot equal 1. See, this right here is where x equals 1. Now, where's my domain? Is my domain down here or is it up here? Well, if you remember from algebra or pre-calculus, whatever you took, so if I take a point above the line, I can take a point above the line or I can take a point below the line. I'm just going to take a point above the line. I'm going to use the point 0, 0 because it's easiest to do. And if I plug that point into here, so if I plug, so I'm gonna use a test point of 0, 0. So I'm gonna plug 0 in for x, 0 in for y. And so I get, oh, that's a 0 there. So I get 1 is greater than or equal to 0. And that is a true statement. So that means it's this side of the line that gets shaded. And I don't know if I will be able to, let me see if I can, yeah, there we go. Let's use this. So it's going to be this part right here that's shaded. Okay, but now I need to come back in here and kind of put that dotted line up above it so we can see it. Okay, so my domain is all of this shaded part, okay, and the line is included, but I can't have any points on this vertical line here where x equal 1. Okay, and so there's the sketch of your of the graph. All right. So let's head on to the next problem. I didn't leave myself a lot of room on this one either, did I? All right. So they want us to evaluate the function at 3, 2. Isn't that right? Yeah, find f of 3, 2. All right. So we have f of 3, 2 is equal to 3 times natural log of 2 squared minus 3, which this is 3 times natural log of 1. And we know that anytime you take the log of 1, no matter what the base is, that's 0. So we know this right here is 0. Okay? And so we know this is equal to 0. And so there's your solution for plugging the point in. All right. Now let's find our domain. All right, so let's look at the function we have, and let's look at this x right here. Well, does it really matter what we plug in for x here? No, it don't matter. X can be anything. Now, what about this part in here, natural log? So hopefully you remember this, that you can't take the log of 0 and you can't take the log of a negative number. Now, if you don't believe me, pause the video, get your calculator out, take the natural log of 0, and then take the natural log of any number. And you'll see it'll give you a syntax error. All right, so we can't take the log of a negative number or 0. So what does that tell me about this right here, the y squared minus x? Well, that tells me that y squared minus x must be greater than 0. Not greater than or equal to, but greater than 0. Okay, and then what I'll do is I'll just go ahead and write this as y squared has to be greater than x. Okay. All right, so my domain is equal to the set of all xy such that x is less than y squared. I just wrote the x first. Why did I do that? I don't know. I just did. Okay. You know, it's just, I don't know. A lot of times you see x first. You know, so if you write y squared is greater than x, that's fine too. Okay. But this is our condition. Okay. So this is your domain. All right. Now let's sketch the domain. All right, so to sketch the domain, all right, so we've got x, we've got y. All right, so I need to sketch the graph of this. Well, do we know what the graph of that looks like if we have x equal y squared? That's a parabola that opens to the right. Okay, and so our graph is going to look something like this. It's a parabola that opens to the right. And notice what I did. I did it in what? I did a dashed line. And why did I do a dashed line here, but up here I have a solid line? Well, I've got the solid line because it's greater than or equal to. But this one is just greater than or just less than. So the graph is not included in the solution. Okay. All right. So now, which side gets shaded? All right. Well, let's look. So for this one, just I can't pick the point 0, 0 because it's on the graph. So maybe just come here and pick 1, 0. So I'm going to come up here. I'm going to choose 1, 0. So if I plug 1 in for x, well, I'm not plugging it into this one. I'm going to plug it into this one right here. So I'm going to plug 0 in for y, and I'm going to plug 1 in for x, and so I get 0 is greater than 1, and that is a false statement, right? All right, so since I have a false statement there, Okay, since I chose a point over here, that's a false statement, so that means I need to shade over here. And so all of this would be shaded, and hopefully, when you shade, you can shade better. Just hard to shade and make it look good on this computer. And and it would be all up here too. Everything else, everything on the outside, not inside here, but outside of that parabola. Okay. All right. So let's continue on to the next problem. All right. So this problem, it says find the domain and range of the function. Okay. All right, so let's look at this. All right, so what do we know? What do we know about this one? Well, once again, we have a square root, don't we? So we know what's underneath that square root has to be greater than 0, or in this case, it can equal 0. All right, so we know that 9 minus x squared minus y squared has to be greater than or equal to 0. All right. Now, that's fine writing it like that and everything, but let's write it a little better than that. Maybe something that we can recognize better. So we can actually write this, and we'll write it like this: x squared plus y squared is less than or equal to 9. Right? That looks better, doesn't it? So all I did is I took the minus x squared minus y squared, moved it over here, and see how the less than's pointing to that. Okay? So my domain is equal to the set of all x, y, such that x squared plus y squared is less than or equal to 9. All right, so there's my domain. All right, so what's the range? What is the range? Well, the range would be the set of all z such that, now remember what we learned at the beginning of the video, oftentimes we write f of x, y as z. Okay, that's what I'm doing here. All right. So it's the set of all values z such that z is equal to the square root of 9 minus x squared minus y squared. Okay. And xy is an element of the domain. Okay. So, that's the range, but let's look at it a little more. Is there a way that we can write this a little better? Okay? Is there a way to write this better? Let's look. Well, the one thing we know that z is greater than or equal to 0, right? So what I'm doing, I'm replacing the f of xy with a z. Okay? So I'm saying that this function is going to be greater than or equal to 0. Because remember, whenever you take the square root of a function, it's positive. Or we could get 0. Okay? All right. So we know that the function, whatever answers we get out, it's going to be larger than 0 or equal to 0. All right? Now, is there something else I know about this? Is there something else? Yeah, actually there is. So I know that 9 minus x squared minus y squared, the part that's underneath the radical, is going to be less than or equal to 9 based on the numbers from the domain. Okay? Because look at this. It's telling me that x squared plus y squared is less than or equal to 9. That's in my domain, right? So just look at this. So if I take 9 minus x squared plus y squared is less than or equal to 9. See, if I factor out a negative there, Well, if this term here is less than or equal to 9, I'm not ever going to get a value. I'm not ever going to get a value larger than 9, am I? I mean, yes, technically I could get a number that's negative, but I also have that restriction that can't happen. Okay? All right, so Bays, let me say that again. I'm not going to get a negative number underneath the radical. Okay, but that's where this is coming from. This 9 minus x squared minus y squared is less than or equal to 9. We know that result, that's going to happen. Okay, so okay, so that's great and everything. Okay, that's what's underneath the radical. But what about the radical itself? Because I'm looking for the output. I'm looking for the range. All right. Well, what this right here, what it also tells me is that the square root of 9 minus x squared minus y squared is going to be less than or equal to 3 if I square root both sides, right? So, looking at this, I can write my range as the set of all numbers z such that, okay, so now let's look at this. Z is larger than 0, right? Z is greater than or equal to 0, but it's also less than or equal to 3. So those are going to be the values that I get out. Okay, that's going to be the values that I get out. That's my range right here. All right. Now I know this problem did not ask us to do this, but let's just do it. Let's graph the domain. So the domain, well, what do I have? I'm gonna graph x squared plus y squared equals 9. That's my circle. Here's x, here's y. So that's a circle with radius 3. Okay, and so I know this is 3, that's 3, that's negative 3, and that's negative 3. All right, and I know my domain. Let's see if I can find a better. Well, I guess we'll use this. And so I know this would be my domain here. See that? So let's draw these, put these lines back in there. Okay, so that would be my domain if I shaded it in. All the numbers inside the circle and the numbers that are on the circle. All right, let's see what we've got now. Okay, so we got a definition here. All right, so let's see what this thing says. It says if f is a function of two variables with domain D, then the graph of f is the set of all points x, y, z in R3 such that z equals f of xy and xy is in D. All right, so this is my attempt at drawing this picture here. Okay, so we have our surface up here in R3. This right here, this is the domain. Okay, this is in the xy plane. And so basically what we have here is this point right here, and notice the point is xy 0. Okay, all these points on here, z is going to be 0 because it's laying on the xy plane. So in other words, the point in the domain here, it's going to have this elevation here, see, f of xy or z, and this is your surface up here. So it's kind of like, it's kind of like this projection down here. This is the domain in the XY plane, but here's your surface up here, your graph. See, there's your D domain, and this is your surface. And so, you know, that's what it looks like. So hopefully that kind of gives you an idea of what we're looking at. All right, so let's look at this. Let's sketch the graph of the function f of xy equals 6 minus 3x minus 2y. All right, so first thing I'm going to do here, I'm going to change this z equals 6 minus 3x minus 2y. So I look at this and, you know, I recognize that looks kind of familiar there, but I'm going to write it in a little bit different form here. I mean, I can write this as 3x minus 2y, plus 2y plus z equal 6. Okay, I just got my x, y, and z on one side, set it equal to the constant. And what is this? This is a plane. Okay, you've done planes already. This is the equation of a plane. All right. Now, let's sketch a portion of the graph. All right. And what I'm going to do here is I'm going to find intercepts. All right. So let's do that. So I'm going to start out by saying x equal y equals 0. I'm going to let x and y equal 0. And so what does that do if I let x and y equal 0? So if I plug 0 in for x, 0 in for y, that's all 0. I get z equals 6. And so that actually gives me the point 0, 0, 6. And then I'm going to let x and z equal 0. And so if I plug 0 into here, 0 into here, I get what? I get 2y equals 6, which that tells me y is equal to 3. So that gives me the point 0, 3, 0. All right. And then I'm going to let y and z equal 0. And so y and z equals 0, that's going to give me 3x equals 6, which that's going to give me x equal 2. And so that's going to be 2, 0, 0. So there's my points there. So now let's sketch the graph. And so let's see, let's draw my y-axis here, x-axis here. There's my z-axis. And let's see, 1, 2, 3, 1, 2, 3. All right, so I got the point 0, 0, 6, and then 0, 3, 0, and then 2, 0, 0. And so here is the portion of the plane. All right, that's a portion of the plane in the first octant. Remember, these are called octants. There's how many of them? 8. All right, and you know, you could shade this in. I'm not going to shade it in, but that's what it would, because it just doesn't work very good with. Well, I'm using a yellow highlighter. It doesn't show up good on this, but anyway, there's your portion of the plane. So there's your graph of it. So that wasn't bad. All right, what about this one? Let's graph this one right here. All right, so we got g of x, y is equal to square root 9 minus x squared minus y squared. All right, so we've seen this graph before. Well, not this graph before, but we did what? We did sketch the domain to this graph, didn't we? So let's go ahead and write this as z equals the square root of 9 minus x squared minus y squared. All right. Now, how do we go about graphing this? All right, so you know this right here is so similar to graphing a circle. Okay, I mean, let's look at it this way. Let's square both sides. So if I square both sides, I get z squared is equal to 9 minus x squared minus y squared. And so that's actually going to give me x squared plus y squared plus z squared equals 9. Okay, so what is this? Well, we can see this is a sphere, right? Sphere. Center at the origin, right? And we have a radius of 3. Okay. Now, so that would be a sphere. So if you're taking notes, I don't know if you are or not, but don't write this, don't draw this. So if we had a sphere of radius 3, okay, that would look something like that, right? You see that? But that's not what we have. Okay, this is a sphere with radius 3. But what do we have? We got the square root. And we know that what? That z is greater than or equal to 0, right? So all we're dealing with is the top half of the sphere. Okay, it's kind of like if you think about a circle. Okay, remember when you had a circle, say x squared plus y squared equals r squared, and you said, okay, y is equal to the square root of r squared minus x squared. That was a semicircle, the top half of the semicircle. And if you had y equals negative square root of r squared minus x squared, that would have been the bottom half, right? All right. Well, we know that z is greater than or equal to 0 because we got a positive here. So the sphere, we only have the top half of it. Okay. And so let's see what we have. Let's see. Let's draw it. So there is y, there's x, and there's z. So I've got 1, 2, 3, 1, 2, 3. All right, so let's see what we can make this look like. So that would be the top half, and then I'm going to come down. Whoop. See if I can't draw that a little better. Then we got this part going back like this. Okay, and there's your sphere. Okay, the top, well, half a sphere, that's your top half of it. And then you see this right here, that's a circle with radius 3, right? That's in the XY plane. That's your domain down there. You see that? That's your domain. All right. So hopefully everybody's okay with that. So let's continue on. Okay, so let's look at this. Definition. Level curves. So the level curves of a function f of two variables are the curves with equations f of xy equals k. K is some constant in the range of f. Okay, so k is in the range of your function. It's a curve in the xy plane that shows where the graph of f has height k above or below the xy plane. I'll show you an example. I'll show you a picture of it in just a second. All right, so that's a level curve. All right, so a collection of level curves is called a contour map. Contour maps are most descriptive when the level curves f of xy equal k are drawn from equally spaced values of k. So in other words, if you want k to be 0, and then say you go to 5, then the next one you would want 10, 15, 20, so on. All right. So contour maps are most descriptive when the level curves f of xy equals k are drawn from equally spaced values of k, and we will assume that this is the case unless indicated otherwise. Okay. All right. So let's look at this graph. So we've got we've got the graph. So down here we have our level curves, and I know I mean, I don't know if it looks like it to you or not, but this is drawn in the XY plane. Okay, and these are called your level curves. Okay, and then these are your horizontal traces. These are the like in other words, this is drawn from an example in the book, and basically what we've got here, this circle out here is k equals, what was it, 20, and then this is k equals 25, this is k equals 30, k equals 35, k equals 40, and then here k equals 45. So basically what you've got here is right here, this right here, this is your 45 here. Okay, it gives you the height. See, remember what it says. Where is it? The level curves of a function f of two variables are the curves with equations f of x, y equals k, where k is a constant in the range of f. It's a curve in the xy plane that shows where the graph of f has height k above or below the xy plane. So on this circle here, it's showing you there it has a height of that 45. Okay, so hopefully that makes sense. I know I'm not the best at drawing these things, so I hope you can see it. All right, and then the other thing I want to talk about, contour map. So if you draw a contour map of a function, and just think about the level curve being lifted up to the surface at that indicated height, then you can kind of see what the picture of the graph will look like. So on the contour maps, the surface is steeper where the level curves are closer together, and they're somewhat flatter where they are further apart. Okay, so where the level curves are further apart, it's steeper, and I'm sorry, it's a little flatter, and where they're closer together, it's a little steeper. Okay. All right, so let's look at some examples here. So an example, sketch the level curves of the function f of xy equals 6 minus 3x minus 2y for the values of k, and they give you the values of k, -6, 0, 6, and 12. All right, so the first thing I want to do here is I want to just go ahead and write this as z equals 6 minus 3x minus 2y. And I'm going to write this, how do I want to write it? I want to write this as 3x plus 2y plus k minus 6 equals 0. Let's write it like that. Let's get everything over to one side. All right, so what did I do here? And I guess I could have done this up here, and I think I might just do that. So what I've got here, you see the z? Well, we're looking for the level curves, right? And so what are we doing with the level curves? F of xy equals k. So, probably been good, just make this a k. And then all I did is I just got everything to one side. I kept the k and the -6. I kept that together. Okay. All right, so now let's sketch the level curves. So we've got k equals -6. So what happens when k equals -6? That's going to give me 3x plus 2y minus 12 equals 0. So I took the -6, plugged in for k. -6 minus 6 is -12. Now, keep in mind, I need to graph these things. So this is just graphing a line, right? And so to graph the lines here, I'm gonna just use the x and y intercepts. So if I let x equal 0, then I solve this for y, I get 6. And then if I let y equal 0, solve for x, I'm gonna get what, 4? Okay, so I'm just doing these points over here so I can graph my level curves, because I've got to graph each one of these lines here. And so so now for k equals 0, I get 3x plus 2y minus 6 equals 0. See, I'm plugging the 0 in for k. And then to find my x and y intercepts, plug 0 in for x, and then I'll get 3 for y. Plug 0 in for y, and I get 2 for x. And then same thing here, k equals positive 6, so that's 3x plus 2y, and that actually just equals 0, doesn't it? Because we got 6 minus 6 is 0. And so, well, I know the point 0, 0's on there, but I do need one other point. So what I'll do is I'll just do this y equals negative 3/2 x, get it in y equals, and then I can use rise and run of the slope to graph it. And then I've got k equals 12, and so that's going to give me 3x plus 2y. And let's see, that's what, plus 6. And so I go to get my x and y intercepts. So when x is 0, I get negative 3 for y. When y is 0, I get negative 2 for x. All right, so let's come over here and let's graph these things. All right, so here. So let's see, we need, say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so for the first line for k equals 6, let's plot the point 0, 6 and 4, 0. So there's this line right here. And this is for k equal 6. And then we just go to the next one. So for k equals 0, I'm going to plot the point 0, 3 and 2, 0. So that's 0, 3 and 2, 0. And so that's this line right here, and this is when k is equal to 0. And then I go to the next one, I've got 0, 0. So I'm at this point, and then I'll use the rise over run. So of course I can go up 3 and to the left 2, or I can go down 3 and to the right 2. Doesn't matter. So we'll go down 3 and to the right 2. And so that's this graph, and this is when k equals 6. And then the last one, I've got the point 0, negative 3 and negative 2, 0, and I draw that line, and this is when k equals 12. And so that's what they were wanting you to do there, is sketch is that all they told us to do? Yeah, sketch the level curves of the function. Okay. And we know this is the graph of a plane, right? All right. You know, if we're in 3D. All right. So let's look at this one. Sketch the level curves of the function. All right. So let's do that. So sketch the level curves, and they tell us k is equal to 0, 1, 2, and 3. All right, so I'm going to have k equals the square root of 9 minus x squared minus y squared. Or we can write this, there's a different way to write this. Let's write it as x squared plus y squared, I'm going to square both sides, is equal to 9 minus k squared. So I squared both sides, moved the 9 over here, or anyway, yeah, moved the 9 over here, and then changed these to plus, so that changed the sign to all of these over here. So there you have it. You know how to solve that. If you're in this class, you know how to solve it. All right. So let's see what we've got. We've got k equals 0, right? I'm going to start with k equals 0. So I'm going to plug 0 in. That's going to give me x squared plus y squared equals, plug 0 in, that's going to be 9. And that's what? That's just an equation of a circle with center 0, 0, 0, and radius 3. All right. Now let's do k equals 1. So I get x squared plus y squared equals, and then let's see, 9 minus 1 squared is 8. So that is center 0, 0, and that is radius square root of 8. And then I've got k equals 2. So I've got x squared plus y squared. So that's 2. K is 2. So 9 minus 4 is 5. So that's center 0, 0. And that is going to have a radius of square root of 5. And then I have k equals 3. And so that's x squared plus y squared. And 9 minus 3 squared is 0. So what does that tell me? Well, that just tells me that's just the point 0, 0. All right. All right, so let's draw these level curves here. All right, so the first one, I've got a circle with radius 3. So that's gonna look something like that. That's radius 3. Now, let's look at our next one. That's the square root of 8. So if we do square root of 8, that's actually 2.8. So that's not very far. That circle's going to be pretty close to this one. Okay. I know that's terrible, isn't it? Okay. So this one, this right here, this is k equals 0. This one is k equals 1. Okay, so center at 0, 0, radius square root of 8. Now the next one, I've got a radius of square root of 5. So if we do square root of 5, that's 2.2. So that'll come in a little bit more. So that's going to be about like right in here. All right, and this would be k equals 2, and then for k equals 3, we just got the point there. Right here, k equals 3. And that would be your level curves. Okay. All right, so hope everything's going good. Everybody's understanding this. It's not that difficult. It's not very hard to do this stuff. I think this is the last thing we have to do, so don't leave. Hang around for the rest of it. All right, so a function of 3 variables, f, is a rule that assigns to each ordered triple x, y, z in a domain where D is a subset of R3, a unique real number denoted by f of x, y, z. All right, so right here, they ask us, find the domain of f. All right, so what's the domain of this function? All right, so what do we know? Well, let's look over here. We know there's something going on here, but let's look at this over here. So we can plug in anything we want to right here for x and y. That's not going to violate some math laws. We can take the sine of any angle, can't we? Any number. So that's not a problem. It's just when we get here to this logarithm. And what do we know? Well, we know whenever we take the log of a number, that whatever that is, that has to be positive, has to be larger than 0, which we also can write that z is greater than y. Okay, I just moved the y over, that's it. So the domain is equal to the set of all x, y, z such that z is greater than y. And there's your domain. And you know, the functions with 2 variables, functions with 3 variables, they're similar in the things that you do. Okay? I mean, you can see when we did the same thing on this, finding the domain. All right? And there's other things you can do, you know, you can graph them. Some of them may be, of course, they're a little more, probably a little more difficult to graph than the other ones we did, but you have graphed these things. Remember, if you remember, you graph quadric surfaces, so you know what to do there. All right, you know how to graph those things. All right, so I think I'm going to call it a video right here. I hope this helped. I hope you learned something. You feel smarter now. But thanks for watching. Check out my other videos. Give me a like, share, and subscribe. And I'll see y'all in the next one. Later.